G'day, mate, and welcome to the Friday Facts number 271, Fluid Optimizations and GUI Style Inspector. And I got Mojo here again.
Hello.
And we're doing this super early in the night again. Yeah.
Yep.
So this is all done by Coverx, and we've got the Game Developers Session 2018. This year, like last year, we're silver sponsor the event, which means you'll see some Factorio branding around the event and in their official booklet. Part of the preparation on our side was to produce a nice graphical asset for their use, which you can see below.
It's a graphical asset.
It is graphical. It is an asset. Everything in the picture is now high res. These are all high res assets.
And it's all in the game?
Well, it's all in 17. When that's released. When that's released, yep. With a large power pole and a medium power pole.
No small power pole, actually.
No small power pole. And don't look at the image too much because everything's wrong with it. Like, from a factory standpoint, none of it works.
Yeah, in terms of actual game mechanics, none of it works. But at the same time, I've seen so many of these pictures over the many decades where none of it makes sense. I sort of don't care.
Yeah. I just... Like, they have some really, really good bases, and like, V does championship bases. Just zoom in on one part and just take a picture. At least it would be a functional, everything works, everything mostly has a reason. I know sometimes he does spaghetti for the fun of spaghetti, but...
Oh, yeah.
Yeah, this is a mess. I'll say it. It's a mess.
It's meant to be visually pleasing. It's not meant to represent actual game. It's pretty normal.
Yeah.
Used to see it all the time.
So, this image is an aesthetic composition to showcase the design and theme of the game and its elements, whilst not necessarily making logical sense. It also contains the first public display of our new official Woob software logo, which they've shoved down this corner, and I'm not a fan of it. I'll put it out there.
At least they're finally trying. It's something that I have complained about a lot, is that like they just need to do the whole professional businessy.
Yeah, look, I agree. It's good that they've got a logo, and had they done it like a week prior, they could have gotten to the Steam Awards. And at least told people where to put their votes. And between the Friday Facts, the Reddit, their forums, there's enough people would have got the information around quickly enough that people could have put their nominations in the right spot, hopefully. But personally, the logo... It's too stretched. The reading the W and the U is very, very difficult. And,
normally with logos, you want something very clean, crisp, clear, and simple.
Yeah,
like you think about any really big name brands, they're always very simple, very clean, and very distinguishable.
Easy to read, easy color code, something you can put on the far side of the wall in a convention center and go, yep, that's EA. I know that's EA. Right.
And they pay professional marketers a lot of money to come up with that logo for specifically that reason.
Yeah, look, I would have settled for a rusty W inside a gear wheel and done. Like, everybody would know what that was straight away.
Well, at least they're trying, because they can always move on from something from you've got to start somewhere.
Yeah, you've got to start somewhere. And
even if it is like 5 years too late.
It is what it is. So, and then we go on to the fluid optimizations. Now, this is the important part, I guess, of this.
This is what we really care about.
Yeah. So we're tracking fluid changes in 3 stages. Moving all the fluid logic to a separate system. Merge the straight section of the pipe into segments. Tweak the fluid flow logic, which will not be as optimized, which will not be an optimization, but a gameplay mechanic improvement, which was covered back in the Friday Fact 260. Which, really briefly, this is how fluid goes currently, where it favors going anti-clockwise, because it does.
Because when it sees a junction, it goes through each orientation one by one, deterministic.
Yeah. And the idea is fluid will flow faster in the new version. The catch is straight pipe, it should be less UPS intensive, but junctions it'll be more UPS intensive. That's probably the quickest way to sum up the old Friday facts from 260. So Dominic has just finished stage 1, so that's moving all the fluid logic to a separate system, and it's been merged into version 17, so it's ready to go. So let me present what has changed and how it helps. The approach is similar to what we did with the transport belts, which we all know was a massive optimization, which let Mojo build an even bigger belt base.
Yeah, and it let me discover a whole lot of new optimizations that need to be made.
Yep.
So, inserters.
Yeah, inserters need another pass. One of the main things slowing down the simulation is every entity handling fluid, pipe, assembly machine with a fluid connection, refinery, mining drill with a fluid connection, pump, offshore pump, has to be kept updated, as its update needs to be called every tick just to update the flowing of the internal pipes. So mining drills and assembly machines are being forced to its logic instead of going to sleep. I didn't know it was also the mining drills and the assemblers. I knew every pipe had to stay active all the time.
Mining drills do take sulfuric acid.
I've never stopped to look at the ones that are doing uranium. I just assume they went to sleep like any normal miner. I never actually checked.
Admittedly, I never actually checked as well. And I always remember, I think the show active state shows assembly machines with fluid as idle for the most part.
Yeah, it does. That one I know because I have gone and looked at, blue circuits and electric engines and made sure that, they say they're off.
Which goes to show you the show active state isn't 100% accurate, because I know there's a few other cases where it's inaccurate.
Yeah,
when there's circuit connections, it says it's always active, but it's not.
Well, see, that's what I'm going on. No, actually, I've had inserters do the opposite. They say they're not active, and they've got a circuit condition, which I know from experience means they are active. Anyway, their own debug window doesn't work. That's pretty much what we've agreed on, right?
Pretty much.
So from the perspective of optimization, every extra piece of data that needs to get to the CPU case, like an extra weight you need to carry around, it slows the whole simulation down. Yes, every single thing you have to process adds more weight to the whole simulation. So the problem is with the fluid pipe memory is scattered around randomly, so we cut all the fluid boxes from the entities using them and put them in a separate system. We call it the fluid manager, and it's storing the fluid boxes like this. So it stores each individual pipe in one, hopefully, continuous chunk of memory. So all your pipe data gets stored together in one stick of RAM rather than spread over all your RAM sticks. Hopefully.
And then the CPU doesn't have to find the byte.
Yeah. So the next step was to divide the fluid box into something called a fluid system. Fluid system is basically all the fluid boxes are connected together. So for example, this refinery setup, there are 5 fluid systems. So it's 1 for water, 1 for oil, 1 for heavy, 1 for light, 1 for petroleum. And hopefully the way you've built it, all the water pipes are stored beside one another in RAM, then all the oil pipes, then all the heavy, then all the light, and then all the petroleum. My first question is, what happens if I contaminate my heavy pipes with water?
Well, then you have 4 fluid systems.
But then does it try to rearrange the RAM, or?
Probably.
That's what I'm worried about. That's what
There'll be some kind of memory management going on.
That's what I'm worried about. That, like, if you contaminate your pipe, straight away you look for a lag spike. Lag spike, I did something wrong. Each fluid system is now its own separate continuous memory of fluid boxes in it. The first advantage is that it increases the chance that neighbouring water pipes are close memory-wise to the original pipe. The cache data from touching into update could still be there when it's being touched as a neighbour. Basically, optimizations. Lots of optimizations.
Yes.
But the second advantage is even greater. The fluid systems are now independent, and fluid flow doesn't interfere with anything else in the map. Their update can be completely parallelized without any worries. So we did just that. The final benchmark on a real fully producing map that uses pipes for production materials and power, nuclear reactors, we're able to see a 6.5 times speed up of the pipes update. The speed up Wasn't so big on less beefy computers, as it depends on the CPU, cache sizes, CPU core count, etc. But still 3 times faster. Also expect the speed up to get bigger with bigger factories, with more separate fluid systems, and also with future CPUs with more cores.
That's interesting there. More separate fluid systems will help speed it up.
Well, before we get onto the graph, so what they've done is they've multi-threaded Factorio. Just for
Another portion of it.
Another portion of it. Like, there is already some multi-threading going in Factorio for those that get on Reddit every week and say, oh, just multi-thread it. It's already happening, and it's already happened, and they're doing more of it. So, good on you, Woob.
There's also a lot of LTT videos as to why that doesn't actually scale.
I know it doesn't actually scale, but it improves things. We all know it does improve things to a certain extent. Yes, you do reach that point where the more you parallelize things, that you end up with diminishing returns and end up taking longer. But that's a job for the technical people, which is not what we're going to be today, because it's 10:30 at night. But yes, newer CPUs with more cache will handle the fluid box in memory system better.
Yeah. I wonder what mine would be, because a 4790 is a pretty antiquated by.
It's around the same spec as my PC.
Yours is a generation newer.
It is.
Still the same processor family.
Yeah. It's one generation up, but it's in the same neighborhood. So,
and there's other issues because it's actually has 2 cores on it that are disabled, but they're still there, and the cache ring's still functioning, so there's extra latency there, and yada yada yada.
Yeah. But like I said, we're not getting super technical tonight, Mojo. But it does make me curious, because we've had Intel, and this is the only part technical bit I'm going to get into. We've had Intel for years now go 1 core, 2 core with hyperthreading, 4 core with 4 hyperthreads, so on and so forth. But the newest generation of CPUs have technically less cores because they're turning off the hyperthreading. But developers are only at the stage now where they're actually using multi-cores in games. Which does make me worry about companies like Woob, that if you parallelize stuff too much, at which point do you end up with more parallel processors that you have CPU cores available and then kill performance on low-end CPUs?
That sounds like a problem for the operating system.
It is, but yeah. And the other thing, I'm going back to the Friday Facts.
I hate to get derailed on a tangent and all.
Yeah. Where was it? It mentioned going back to the Friday Facts 260 with the smarter pipes. No, I kind of find it. More separate fluid boxes, also with future. No, I don't know. There was something else I was concerned about. It's written underneath. So yeah, the update performance. So when they added fluid boxes in the manager, so that's going all the way back to this step, just a nice little fluid box.
Yeah.
They got a 13% increase, and then putting it as a fluid system, so parallelizing it, they got a 38% increase. Doing the memory pooling, I guess, without the fluid systems?
I'm not 100% sure what each of these graphs represent.
Because I don't see how you could go down when you added memory pooling.
Memory pooling would be collecting all the memory together. Yeah, unexplained intermediary steps. Yeah. So, the memory pooling is the gluing the memory in the same area.
Yeah, but that's already part of the fluid system.
Unless it's fluid system without memory pooling.
That's all I can assume. I don't know. Small vectors for connections, no idea what that is. Merging with prototypes. So that's merging.
I think that's code-based movement.
Yeah. Prefetching 2 pipes ahead. Brought it up to 51%. Yeah. And then prefetching 100 head. Brought it up to 72% increase. And then parallelizing with no prefetch. So that's the point when they actually took it off and put it on a second CPU. Okay, so that's the core one there. So it's a 78% increase. Now I'm wondering what happens if they added prefetch to it.
Unless it already has prefetch in it.
Well, it says parallelization, no prefetch. So what's parallelization no with prefetch? That's what I'm curious about now.
That's something for people who know more about cache optimizations. That's very
well, they did say in a previous Friday Facts that there isn't that much cache optimizations they can do because generally the CPU just handles it and the code doesn't need to.
Yeah, it just does what it wants.
Yeah. But yeah, just a reminder, this is stage 1 before actually merging straight pipe sections in one fluid box, which should improve things again. That's the bit I was looking for. Even with systems with a lot of branching, as even 2 fluid boxes merged into one should help. In this example, in the example of the refinery set up above, it seems that the fluid box count could be reduced by a factor of 4 or so. So I guess they're talking about making all the water and all the petroleum, or all the oil, all the petroleum, all the light, and all the heavy, one single pipe entity. That's
something like that.
Only thing I can imagine from that line at the bottom. I don't know. But yeah, it does say, but before actually merging straight pipe sections into one fluid box. So currently, if you've got 10 bits of straight pipe, and we all know this because we've all preached it forever, 10 bits of straight pipe are 10 bits of pipe that each have to be calculated. If you use an underground to go that distance, it's 2 bits of pipe. 1 to go down, 1 to come up. And the idea that they're trying to get to is if they make 10 bits of pipe, 10 bits of pipe become one single bit of pipe.
Yeah, because it's all contained within that fluid system contained.
Yeah, but the thing is, from our point of view, as a megabase builder, we don't have straight pipe. We don't have any straight pipe unless pretty much ever. It's all junctions.
Yep. Well, actually, I do have a lot of runs, but a lot of runs of under. But it would still get divided up into the fluid system. I think it's a wait and see what happens.
It really is a wait to see what happens, right? Because the next line is that should make the savings big enough to justify the planned 2x slowdown of the future fluid flowing algorithm, as we'll probably need 2 passes to make it work good enough. Dominic will have an update on the algorithm and conclusions from the previous discussions in a future Friday Facts. That's the bit I'm worried about, because they said back in 260 that it was a lot slower. It was more predictable, but it was slower.
And that's the other thing too, was that being able to hover over a pipe and actually know what it's doing, that would be nice. That's another separate issue entirely, though.
Being able to hover over a pipe and see that it has a amount of liquid passing per second in which direction. Ideally, like if we're making prayers to the great woob gods, I want to be able to put my mouse over and say, "Hey, you've got, 10 oil per second going that direction." I'm like, great. And if it's ever flowing the wrong direction, I know I've obviously got a problem. So next we have the GUI style inspector. The implementations of several GUI redesigns in progress has been done by several team members. Suddenly we realized that coordinating more people brings new problems. What a surprise. Mojo's comment?
What a surprise.
Okay, I was expecting something witty. We have started...
I was just thinking about the previous thing.
Oh, still
you bring an offering of green beans.
Okay.
As an offering to the Factorio woob.
The woob, okay. We started to have a mess in the styles. Everyone's inventing their own styles for the GUI to be the same as the graphical mockups given by the graphics department. After some discussions on how to solve this, we finally realized that we mainly need some common language with the graphical department when it comes to style hierarchy names. For what we need, everybody has to quickly inspect which styles are being used, where and what it is in the hierarchy. For that reason, we made the GUI Style Inspector. By pressing our key, Control F6 by default, every UI element will show a tooltip with the information about the widget and its style, and will highlight the widget as well. Yep, this seems fairly logical and should have been implemented quite some time ago.
I noticed you said finally. You instead of finally, when it was we realized, you said we finally realized.
Oh, did I? Well, it definitely needs it. This tool.
This is way overdue because there's the files. The style standard is just all over the place.
Yeah, well, they get down here. This tool, even when it's quite easy to add, it immediately became very useful, and it has already helped us clean up some mess, and should improve the work efficiency when it comes to further GUI implementation. The main reaction when I showed this to the rest of the team, and this is Covrex, don't forget, this is the owner of the company, the head developer. The comment from the rest of the team was, "Why didn't we have this earlier?" Well, better late than never. Oh, it's just like Word has a nice simple like heading 1, heading 2, heading 3, heading 4, and it's intentionally done like that. So everybody knows when you're working on group documents that like heading 1 is the most important, heading 2 is the second, third is you just quick select and it just does stuff for you automatically.
There's even a button to sort it out for you.
Yeah, and like you'd think with multiple people working on the same thing, you'd be like, these are the ground rules. Like, don't reinvent the wheel because every line of code takes time to write. If you can copy and paste somebody else's code, which is actually what I did for the next month's community map, which starts in like 12 hours roughly.
Plagiarismo.
Yeah, look, somebody wrote some good code. Well, some bad code, which I stole and improved. But like, if you can copy and paste something, you copy and paste something because it takes half a second to copy and paste and it takes you 10 minutes to rewrite it. And that's really what it comes down to. Like, just copy and paste, like start the next wave button. Yep. Find a button that already works, copy and paste, done. Change the width.
Doing scenario code to do that kind of thing is so painful to do it by scratch.
Look, scenario code is horrible, but yeah, I'm not going to get there at all. That's 20 hours of slamming my head against the table, and I finally got it to work.
Just a copy code, and that wasn't like. Can you imagine how long it would have taken if you'd have actually written?
Oh no! It was to unbreak the existing code. Okay. Like I ran the game for an hour. The event was normally designed to run for 5 hours. I ran it for an hour at like 600 game speed, and which was like 10 minutes real time, and it wrote a 20 meg log file for an hour's worth, and the UPS went from 400 to 80. By the time it got to 2 hours.
UPS.
2 hours into the game, it was running at 40 UPS, and there was nothing on the map. It was great code.
It was all going into the scripting.
It was all going to updating shit every second and log files. And whole separate story, and this is why I don't code. But yeah, Friday Facts 271. Any comments? Any thoughts? Any last minutes?
What does the orange mean in the style? It doesn't actually say. It mentions red, green, and white, but it doesn't say what orange means.
I got that as well, and the only thing I could gather is like style is play tutorial button derived from button. I'm guessing it links to something else. So red was the value that's needlessly redefined, which was happening a lot, being font default.
Unless it means from white, it means yellow.
Maybe. No, because we got white, a style value that is not used as is overwritten by a descendant style. So we got font default at the top with font default underneath. Obviously the second one is not needed because it's already written above.
Yeah.
And the first one's not needed because if you don't specify a font, obviously the game's going to automatically choose default.
Which makes sense.
And green, the style value that is being used, which is blah, all that crap.
Yeah, all that.
So the only thing I can guess is the orange. The only thing I can guess is it's not. It links to existing code. And I get that from...
Or it's telling you what it's referring to.
Maybe. Like style play tutorial button doesn't really mean anything, but it's derived from button. Derived from button means I assume it's linked to the bit of code that handles buttons. I'm assuming. I'm not sure. I make assumptions. I've played with Lua for 20 hours this week, and I hate myself for it, and I hate Lua. Officially, it's done.
You love it.
No. No.
I don't.
Anything else you want to add?
Nope, that's everything.
Okay, well that covers us for Friday Facts 271. As always, link to the blog post will actually be down in the comments if you want to click it, but I've highlighted all the stuff, we've covered all the important stuff. I'm going to leave it there, so thank you guys for watching, and we'll catch you in the next one. Alright, bye!